So let's discuss about other interview questions. In terms of natural language processing (NLP), the question is how does the transformer architecture work? Okay, so the answer would be basically transformer rely on self attention. The whole keyword is self attention mechanism to process sequential data. The whole point is to process sequential data, of which the transform architecture, enabling parallel computation and capture. So it has to enable parallel computation and capturing long range dependencies. Okay, it has to enable computation and it has to enable parallel computation and long range dependencies. In my sentimental analysis project at Global Payments, I used a transformer based BERT model. So, BERT model to process 50k plus customer reviews daily. So, this is the BERT model. So, this is where the transform architecture is, and it relies on self attention mechanism. And it enables parallel computing and it captures long range dependency. Next, what is the difference between Word2Vec and BERT? Okay, Word2Vec and BERT. What is the difference? So basically, Word2Vec generates static word embeddings. It generates static word embedding, while BERT provides contextual embedding, that is static word embedding and this is contextual embedding. Okay, using bidirectional attention. Okay, so using bidirectional attention. So there was self attention and this is bidirectional attention. In my NLP based sentiment, I used BERT for better context understanding and achieving higher accuracy than Word2Vec. Okay. Next, how do you process text data for NLP task? How do you pre-process text data? Okay, how do you pre-process text data for NLP task? The answer is basically I pre-process text by tokenizing. So the keyword is tokenizing, removing stop words, lemmatizing and encoding, removing stop words, lemmatizing and encoding. So these are the things which I do. I prepare text by tokenizing, removing stop words. So all these actually, tokenizing, removing stop words, lemmatizing and embedding. So these are the things which I do. Okay, pre-process data for NLP tasks, tokenizing, removing stop words, lemmatizing and encoding. For my sentimental analysis project, I use SPACY for pre-processing and Hugging Face transformers. So this is the thing, right? Hugging Face transformers, Hugging Face tokenizer for BERT inputs. So I used SPACY for pre-processing and Hugging Face for tokenizer. Okay, pre-processing and Hugging Face for tokenizer. That's the thing. Okay, next, what challenges have you faced in NLP projects? Yes, challenges in NLP projects. Challenges include handling noisy data, domain specific jargon and computational cost. Handling noisy text and computational cost. In my Global Payments project, I address noisy customers by cleaning data with NLTK, and fine tuning BERT to adapt to financial terminology. I addressed noisy customer reviews by cleaning data and fine tuning BERT to adapt to financial technology. Next, how do you evaluate NLP models? Answer: I use metrics like accuracy, F1 score, and BLEU for tasks like classification or generation. So these are the three: accuracy, F1 score, and BLEU for tasks like classification or generation. For my sentimental analysis model, I used F1 score to balance precision and recall. Ensuring robust performance on 50K plus daily reviews. Computer vision. Next question: what is YOLO algorithm? How do you use it? Okay, next. YOLO is you only look once. Is a real-time object detection algorithm. Using a single neural network. To predict object detection algorithm using a single neural net to predict bounding boxes and class probability. Okay. In my real-time object detection project, I used YOLO for retail inventory management, optimizing it with TensorFlow. Lite for 60% faster. Okay, next. So what was the question actually? What is YOLO? YOLO is basically a object detection algorithm using a single neural network to predict bounding boxes and class probability. I use YOLO for retail inventory management, optimizing it with TensorFlow Lite for 60% faster inference. Next, how do you handle data augmentation? In computer vision? Answer: data augmentation involves techniques like rotation, flipping, and scaling. To increase rotation, data augmentation involves technique like rotation, flipping, and scaling. To increase data set diversity. In my defect detection model, I used OpenCV for augmentation like rotation and brightness adjustment, improving model robustness and achieving 94% accuracy. Next, what is the difference between RSet and efficient net? So basically, RSet uses residual connections to ease trainings of deep networks, while efficient net balances depth, width, and resolution for efficiency. In my defect detection project, I used ResNet for its robustness, but I have also experimented with EfficientNet for edge devices. Okay. Again, let's revise. So where did we start? We started with NLP. So how does transform architecture work? Transformers relies on self-attention mechanism to process sequential data, enabling parallel computation and capturing long-range dependency. Okay, what is the difference between word2vec and BERT? Word2vec basically generates static word embedding, while BERT provides contextual embedding using bidirectional attention. Next, how do you pre-process text data for NLP tasks? I pre-process text by tokenizing, removing stop words, lemmatizing, and encoding. Next, what challenges have you faced in NLP projects? Challenges include handling noisy data, domain-specific jargon, and computational cost. Next, how do you evaluate NLP model? I use metrics like accuracy, F1 score, BLEU for tasks like classification or regeneration. Next, computer vision. What is YOLO algorithm? How did you use it? YOLO is basically you only look once. Is a real-time object detection algorithm using a single neural network to predict bounding boxes and class probabilities. Next, how do you handle data augmentation in computer vision? Data augmentation involves techniques like rotation, flipping, and scaling to increase dataset diversity. Next, what is the difference between ResNet and EfficientNet? ResNet basically uses residual connections to ease training of deep networks, while EfficientNet balances depth, width, and resolution for efficiency. In my defect detection project, I used ResNet. That's all.